Hi, everyone. Just wanted to take a minute to talk a little bit about graphing inequalities in two variables. So basically, what you're going to be doing with this is you're going to look at this, you're going to be graphing lines, and then you're going to shade which side um, that you need to shade in to have the correct answer. So as you might recall, inequalities would have infinitely many solutions, right? When we had stuff like when we had stuff like x is greater than 3, right? You could plot it at 3 with the open circle, and we're saying anything bigger than 3, that works. Um, so we're saying that there's infinitely many solutions to this. Same thing applies when we have the two variables like that. It's just now we have the graph in terms of two different dimensions. So the first thing that you're going to do when you get something like this in terms of graphing the inequality is you are going to start off by graphing the line itself, right? So we're going to start down here at the y-intercept, -6. Then we're going to go up 1 to the right 3, up 1 to the right 1, 2, 3, right? So nothing has changed at this point. However, we need to be careful. So at this point, we have a less than symbol, all right? Because we have a less than symbol, that essentially is saying this boundary line right here, we can't include it, right? That was the situation, right, where if we had like x is less than 3, we couldn't include 3 in our answer. We just say anything up to, but not including 3, right? So we need to illustrate that on the line. Now, when we have just a less than or a greater than, we do need to change the line to dashed, all right? So what you would be doing instead is you want to make sure you have a dashed line. Essentially what that's saying is this is kind of our boundary. We're going to get infinitely close to it, but we will never touch it, all right? So that's why we cannot include it. If this was an equal to, different story. We would leave it as a solid line. But because it is just less than, we have to have it as a dashed line. We're saying we're not including the line itself. Now, we have this other thing that popped up called change shade, right? So remember when we were saying with like x was less than 3, there are infinitely many solutions as long as it's less than 3. Same thing with this. We're saying if we plugged in 2 points, half of this coordinate grid, so to speak, would be shaded in, and the other half wouldn't be, right? Same thing with a number line, right? If we had something like this half over here, anything over here works, anything over here doesn't. Same thing is going to apply over this. And there's a couple of things you might have heard, right? Less than, shade below, things like that. My way of just making sure, because sometimes the orientation of the line makes it hard to tell, is plug in a point. And if it works, shade that way. If it doesn't work, shade the other way. So my favorite point to plug in to confirm whether or not this works will be 0, 0. The only time you won't plug in 0, 0 to check is if 0, 0 is actually on the line itself, because that doesn't give you any information. So you just can pick any point not on the line and determine which way you're going to shade. All right, so if I plug in the point 0, 0, for x and y, I'm going to plug in 0 is less than 1/3 times 0 minus 6. So 0 is less than -6. Well, is that true? No, it's not true. 0 is not less than -6. So what we're going to do is we are going to shade the side that does not include 0, 0. So we can't choose that side. We have to choose the side below in this case. So you probably heard less than, below, greater than, above, things like that. But again, sometimes I personally find it hard to tell which is above and below, depending on how the line's kind of tilted. And I just prefer to check with a point. Okay, so I'm always going to check with a point. Whatever works for you, but I'm going to show a couple examples where I check with a point. All right, so less than, shade down, shade down. All right, let's look at another one. Ooh, I like this one. So let's remind ourselves, we have this in standard form. So there's a couple things that we can do here. Well, we have it in standard form. We can either graph it by bringing everything, getting it in terms of slope-intercept, or we can find the intercepts, right? So how do I find the intercepts? I set them equal to 0. If I set y equal to 0, right, If I ignore that, I would get 5 halves. If I set the other one equal to 0, x equal to 0, -5. Okay, so we have over 0, up, down, -5. We also have over, nope, and they're not going to let me do that. All right, so because I can't quite plot a half, let me rewrite it. So I would have 2x minus 5 is less than or equal to y, right? So if I were to rewrite that, I would have y less than or equal to 2x minus 5. So we are starting down here at -5. We're going up 1, 2 over 1. Though you can see right there, it's going right through the middle. It is going through 5 halves, just as a heads up. So that is, as a quick reminder, a way that you could write it in terms of standard form. All right, so again, I'm going to check with a point. I'm going to plug in 0, 0. So is 0 greater than 5? Well, no, so I'm going to shade this way. Okay. Because it did not work, I have to shade that way. And the other thing, too, is that when you rewrote it, it was the less than, shade down. Okay, there we go. Oh, the other thing I completely forgot to tell you on that one is, remember, we included the line. We didn't make it a dashed line because it was a equal to as well, right? So we do need to be careful of that. I forgot to completely mention that. So let's look at this one as well. We have plus 8. Oops. So we have plus 8. We go down 1 to the right 2. And we do leave it as a solid line because it is greater than or equal to, because we need to include it, right? We do need to include it because essentially this is saying, this was like the situation where you did the, the closed circle at 3 or the bracket at 3. We're saying that we do have to include it. All right, so again, I'm always a fan of plugging it in just to make sure I can double check. 0 is greater than or equal to 8. So that's not true, so I'm going to shade above. Okay. I'm going to shade above. Let me change my shade. Shade above. Double check. Okay. So again, greater than, shade up. And again, you can kind of use that little device to remember greater than, up, less than, down. I always like to check to make sure that I do it correctly because I always feel like I'm going to screw up. But it's your personal choice. All right, so let me know if you have any questions, and have a great day.